Hi everybody, welcome to topic number 14, factoring trinomials. For today's objective, we're going to show you how to factor trinomials when the leading coefficient is both equal to 1 and not equal to 1. So again, this continues our series on factoring, where we're doing the reverse process of multiplying. It is the process of writing a polynomial as a product. Again, here's our flow chart of different ways that we can be able to tell how to factor polynomials based on the number of terms. Today we're going to look at two of the ones from 3 terms, where we're doing the factoring by guess and check, which we're actually going to call today the A equals 1 method, and then factoring by the AC method, which we'll also refer to today as the A is greater than 1 method. Again, the previous videos we went through, we showed you how to do factoring by doing the greatest common factor, which we still have to look for today, as you could do a GCF with any sort of polynomial. And then we did factoring by grouping, which we did with the 4-term polynomials. But today's are all about trinomials. So all of our terms today will have 3 terms. Factoring by guessing and checking, but when A is equal to 1. When factoring for a trinomial, we're looking at the coefficient of the highest degree. If there's no number in front of the term, then the coefficient is equal to 1. And trinomials are often written in this form, ax squared plus bx plus c, where the leading coefficient is a and the constant is c. So if there's a no number here in front of the x squared, we're assuming that that means a is equal to 1. When a is equal to 1, to factor it, we need to find two numbers that multiply to the c term and combine to make the b term. So we're looking at the constant. What numbers can multiply to make the constant that can combine to make the b term? One of the things that we'll also remember as we're doing this is signs matter. So if the constant's positive, it's got to multiply to be a positive number. And if the constant's negative, it's got to multiply to be a negative number. Same thing with b. If b is positive, it's got to combine to make a positive number. And if b is negative, it's got to combine to make a negative number. So keep that in mind as we go through this video, that signs do matter. Let's show you some examples of a equals 1. So I have x squared minus 2x minus 35. Again, no number in front of x squared, so this is a equals 1. I need to take the c term, which in this case is negative 35, and find a way to make the two numbers become negative 2. So I'll do this by listing out all the multiples of 35. 1 and 35, 5 and 7. I need something that can become a 2. Well, between 1 and 35 and 5 and 7, the only one that's going to work is 5 and 7. But now I have to combine these and make them into a negative 2. Well, if they're negative, that means the signs have to be different when I multiply it. And if I want it to be a negative 2, that means the bigger number has to be negative. So I'll put the negative here and the positive here. Now double checking, 5 minus 7 is negative 2. And 5 times negative 7 is negative 35. So we've selected the correct two numbers. This gives us our final answer, x plus 5 and x minus 7. So a reminder, you can also write it the other way, x minus 7 and x plus 5, and you would have the correct answer. Let's do the same thing for the next problem. I've got to find something that multiplies the negative 28 and adds to negative 3. So when I look at 28, I've got 1 and 28, 2 and 14, 4 does not go, 4 and 7, and that's it. Trying to find one that's 3 apart, I've got 4 and 7. It has to multiply to a negative number, so these signs have to be different, and it has to make a negative 3. So again, the bigger one has to be the negative. So in this case, my answer would be y plus 4, y minus 7. Same thing down here. C is 12. B is negative 8. I got to find two things that multiply to positive 12 that make negative 8. I've got 1 and 12, 2 and 6, 3 and 4. The only thing that can get me to an 8 is 2 and 6. I have to multiply it to make it positive, which means both the signs have to be the same. But the only way I'm going to make this a negative 8 is if both of these are negative. Negative 2 minus 6 is negative 8. Negative 2 times negative 6 is positive 12. So my answer is simply x minus 2 and x minus 6. Same thing with our last problem over here. It's got to multiply to negative 40 and add to negative 6. I've got 1 and 40, 2 and 20, no 3, we'll go 4 and 10, and then we'll go 5 and 8. The only way I can get a 6 is with a 4 and a 10. I need this to be a negative 6, and I need the signs to be different to make it a negative multiplication. So negative 10 and positive 4. M plus 4, M minus 10. So again, multiplying to C to try to combine to make the middle term. A couple additional problems here. I got to multiply to C, which is negative 42. And I notice here my B term, there's no number here. We'll pretend that there's a 1. So this is really a negative 1. So I need to find two numbers that are basically next to each other. I've got 1 and 42. I've got 2 and 21. I've got 3 and 14. I've got 6 and 7. And I need numbers that make a 1. 6 and 7 will work. I need it to be a negative 1, so it's got to be a negative 7 and a positive 6. So I've got x plus 6 and x minus 7. Now, be careful on some of these problems. Make sure you write out your factors. Here I need something that multiplies to 24 that's going to combine to negative 10. So I've got 1 and 24, I've got 2 and 12, I've got 3 and 8, and I've got 4 and 6. So a potential problem I have here is that I've got two sets of multiples that can technically make 10. Both 2 and 12 and 4 and 6 work. I need this to be a negative 10, and I need this to be a positive 24. So if I wanted this to be a negative 10, and I wanted to use 2 and 12, the only way that would work is if it was negative 12 and positive 2. The problem I have there is that 2 minus 12 is negative 10, but 2 times negative 12 is negative 24. That means this does not work, because this needs to be a positive 24. But here if I used 4 and 6, I need both of these to be negative numbers. Negative 4 minus 6 is negative 10, and negative 4 times negative 6, double negative makes a positive. So we would use this one. So my final answer would be x minus 4, x minus 6. Make sure you list out all your multiples and make sure that it really does multiply to C and combine to make B. Now, potential problem with the last two. You'll notice A is not in 1 anymore, so we can't use A equals 1 method. However, we notice that this is a 2, and all of these are multiples of 2. So in fact, we can take out a 2 as a GCF. So we're going to divide all the terms by 2. 2n squared divided by 2 is just n squared. Negative 38 divided by 2 is negative 19n. And 80 divided by 2 is 40. Now when I look inside the parentheses, this I can do with a equals 1, because nothing in front of the n squared now. So let's go through and factor it. I need something that multiplies to 40, but combines to make negative 19. I've got 1 and 40, I've got 2 and 20, I've got 4 and 10, and then I've got 5 and 8. So as I look through this, 1 and 40 don't make 19, neither does 2 and 20, neither does 4 and 10, and neither does 5 and 8. So what does that mean? That means this cannot factor any further, and this would be my final answer. Let's do the same for the next problem. Again, there's a number in front of the y squared, but all of these terms are factors of 3, so we're going to take out a GCF of a negative 3. Taking that out, negative 3 divided by 3 is a y squared. Negative 15 divided by negative 3 is a positive 5y. And 42 divided by negative 3 is a negative 14. Now that we've done that, let's check and see, can we factor this any further with a equals 1? Is there anything that multiplies to negative 14 that can combine to make a 5? Well, 14 is 1 and 14 and 2 and 7. I can use 2 and 7 as long as I need a positive 5, so positive 7 minus 2. So this will factor out to be y minus 2, y plus 7, and the negative 3 just comes down as our factored out part. So again, remember, we could take out a GCF from anything, we have to check and make sure if we can take out a GCF before we go through and factor it. Here's a great example of that. On the one with the 2n squared, we could not factor it any further, so we left it as is. But on the negative 3y squared, we could factor the inside further, so we finished the problem. Factoring when a is greater than 1, factoring by the AC method. So again, we'll have ax squared plus bx plus c, but now there is a number in front of x squared basically, and it's greater than 1. So we're going to use this idea of the AC method, which is literally just a combination of a equals 1 factoring and grouping. The first thing we're going to do is multiply a times c to make b. So in a equals 1, we just use c to make b, but we're going to do a times c to make b. Once we find those two numbers, we're going to rewrite the middle term with the two numbers we found in step 1, and we're going to include the variable that was with it. So we're going to take it from something that is a 3-term polynomial into something that is a 4-term polynomial. And the reason we do that is because when we have a 4-term polynomial, we can finish it by factoring by grouping. So we'll take everything we've done with factoring by grouping and finish the problem that way. Let's show you an example on this one. So again, a is 6, so I have to do the AC method. So I'm going to take a times c, which is 6 times negative 12, making sure we're going to include the sign for anything that we need to. 6 times negative 12 is negative 72. It's got to multiply to negative 72 and add up to negative 1. So I'll list out my factors of 72. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. I got to find something that will make a negative 1. The only thing that can do that is 8 and 9. I need it to be a negative number, so that means the biggest number has to be negative. 8 times negative 9 is negative 72, and 8 minus 9 is negative 1. Now if this were a equals 1 method, we would be done. But now what we're going to do is we're going to take these numbers, and it's going to replace this middle term here. So when I go to do this, these two parts are going to stay the same. The 6x squared and the negative 12 don't change. But this will now change into what we just found. And we're going to put an x on each of the terms. So this will now become 8x, and this will become 9x. 8x minus 9x gets us back to negative x. And again, the reason we're doing that is now we can finish this by doing our group factoring. If I were to do this by group factoring, we would have 6x squared and 8x. 6 and 8, the biggest number I could take out of there is a 2. X squared and x, I can take out an x from each term. 6 divided by 2 is 3. X squared, take away an x is x. 8x divided by 2x is 4. Here from my second group, remember if we start with a negative, we factor out a negative. 9 and 12, the biggest number I can take out is a negative 3, and I can't take out any x's with it. Negative 9 divided by negative 3 is 3x. Negative 12 divided by negative 3 is positive 4. Again, we did it correct. These came out to be exactly the same. So my answer should be 2x minus 3, what I had on the outsides, and 3x plus 4. Now, I do want to make sure and go back and say, if you put these middle terms the opposite way, so for example, I did 6x squared minus 9x plus 8x minus 12. So I put the 9 first and the 8 second. We still should get the same answer. Let's try it and see. 6x squared minus 9x. 6 and 9, I could take out a 3. X squared and x, I could take out 1x. 6x squared divided by 3x is 2x. 9x divided by 3x is 3. 8x and 12, what can I take out of 8 and 12? That would be a 4. 8x divided by 4 is 2x. Negative 12 divided by 4 is negative 3. Again, I get the same on the inside, and my answer should be exactly the same that I have here. So it does not matter which way you place the terms when you do the a times c part, as long as they take over the middle term as you're doing it. Let's try again here. So A times C, so 12 times 6 is 72, and I need it to equal negative 17. So I've got all my multiples of 72, and I'm looking for whichever one can give me a 17. In this case, we're going to use 8 and 9. They need to both be the same sign because it's going to multiply to make a positive number, and that sign is going to be negative because I need this to be a negative number. So negative 8 and negative 9. When I go to rewrite it, I still have the 12y squared, but now I'm going to do it minus 8y, minus 9y, and then I'll add the 6 at the end. Let's factor the first group. 12y squared and 8y, 12 and 8, I can take out a 4. Y squared and y, I can take out a y. 12y squared divided by 4y, 12 divided by 4 is 3. Y squared divided by y is y. Negative 8 divided by negative 4 is negative 2, with the y's canceling. Let's do the same for the second group. It starts with a negative, so our factor has to be negative. 9 and 6, I could take out a negative 3. I can't take out any y's because the 6 does not have any y's. Negative 9 divided by negative 3 is positive 3, with the y dropping down. 6 divided by negative 3 is negative 2. Again, these came out to be the same. So my final answer should be 4y minus 3. And then 3y minus 2. Remember, we're just taking the outsides and putting them into one, and one of the same and putting it into the other one. We're going to do the same thing here. We'll just make sure when we replace the middle term, it gets both an x and a y as I go through and do it. A times c is 12 times negative 12. So it's got to multiply to negative 144 and combine to make negative 7. A lot of multiples for 144. Let's make sure we get them all out here. We got 3 and 48. We got 4 and 36. 6 and 24. 8 and 18. 9 and 16. 12 and 12. I'm looking for something that can give me a 7. 9 and 16 is what I'm going to use. Negative when I multiply it, so both these signs are different. The bigger one needs to be negative. So I'm going to write it as a positive 9 and a negative 16. So when I go to rewrite this, I still have the 12x squared, and I still have the negative 12y squared. But now my middle two terms are going to be with 9 and 16 with the x and the y. So I'm going to call this a positive 9xy and a negative 16 xy. And then we'll go through and do our grouping. 12x squared, 9xy, 12 and 9, I could take out a 3. X squared and x, I could take out 1x. From the y, I can't take out anything because this term doesn't have a y. So we're just taking out a 3x. 12 divided by 3 is 4. 2 x's, I take away 1, I have an x. 9 divided by 3 is 3. The x goes away, and the y stays there with it. Let's do the same for the second term. Negative 16 to start, so our factor has to be negative. Negative 16 and negative 12. The only number that can go into both 12 and 16, or the biggest number I should say, is negative 4. I can't take out any x's, but I can take out one y here, because each of the terms has at least one y. Negative 16 divided by negative 4 is positive 4. The x comes down. The y's cancel out. Negative 12 divided by negative 4 is positive 3. 2 y's, I take away 1 y, and I have 1 y. Again, we got the same for our parentheses, so that's our check to make sure we did it correct. Our final answer should be 3x minus 4y, what I had on the outsides in green, 4x plus 3y, what I had on the insides in blue. When I look at this one, again, AC method, because there's a number in front of A. So I've got 7 times negative 3 which is negative 21. It's got to combine to make negative 4. So for 21, I've got 1 and 21. I've got 3 and 7. That's the one that's going to get me a 4. I need this to be a negative 4. So this has got to be like that. Now in this case, I'm actually going to switch the terms when I write it. So I'll put the 7x squared here and the minus 3 here. But this time, I'm going to deliberately put the negative 7 that I found here first. And my reasoning behind that is because that'll make this GCF easier when I go to do it. 7x squared and negative 7x. They both have a 7 and they both have 1x. 7 divided by 7 cancels. 2 x's, I take away 1, just leaves me with x. Negative 7x divided by 7x is just negative 1. When I go to my second term, I've got 3x minus 3, so I'm going to take out a 3. When I do that, I'm just left with x minus 1, 7x plus 3, x minus 1 is our answer. Again, I don't have to flip the terms here. I can still write this 7x squared plus 3x minus 7x minus 3 and be okay with it. And watch as I do it, because maybe we'll want to make sure that we're factoring out everything correctly. So if you did it this way, the only thing you could factor out of this first group is an x, because 7 and 3 don't have any common factors. Taking away an x from everything, 7x squared becomes 7x, and 3x becomes 3. From the second group, I have to factor out a negative. 7 and 3 don't have any common factors. The x don't have any common factors because the 3 doesn't have an x. We have to factor out a number here, so we have to make sure it is a 1. Or if you can't factor out anything, we put it as a 1. And this time we'll call it a negative 1 because this sign is negative. Negative 7 divided by negative 1 is 7x. Negative 3 divided by negative 1 is positive 3. So either way I do it, again, I get the same answer. But to me, I think this way might be a little bit easier just to know when you do it. So as you go to place your terms, make it make logical sense for you if you want to make the factoring a little bit easier. Our last problem here, we notice a couple things stick out. One, there's multiple variables in this, but hopefully the thing we notice right away is that we've got 12, 22, and 8, which those are all divisible by at least 2, and they all have y's in them, and they all have x's in them. So again, we can take out a GCF, and we have to watch and make sure and see, is there a GCF that we can take out? In this case, 12, 22, and 8. I can't take out an 8 from 12. I can't take out a 4, but I can take out a 2. Each term has one x and one y that I can take out. So I'm going to divide everything by 2xy. 12 divided by 2 is 6. 3 x's, take away 1x is x squared. Y, take away the y, that cancels out. 22 divided by 2 is negative 11. 2 x's, I take away 1x, that leaves me with x. Here again the y cancels. 8 divided by 2 is 4. Here the x cancels, and the y cancels with this. Now, this I can use the AC method on. It's still 3 terms. There's a number in front that's bigger than 1. And I can go through and I don't have multiple variables. So now when I do this, if we think of it like this, this is ax squared, this is bx, this is c. I need something that multiplies to ac, so 6 times 4. I need to multiply to 24, but combine to make negative 11. I got 1 and 24, 2 and 12, 3 and 8, 4 and 6. The only thing that could give me an 11 is 3 and 8. It has to be positive, so these signs have to be the same, and they both need to be negative to make that a negative 11. So again, we're going to ignore the negative or the positive 2xy for a second. This is now going to come down. I have a 6x squared. I have a negative 3x. I have a negative 8x. And I have a positive 4. So again, I took the negative 3 and negative 8, and I replaced the negative 11 with it. Let's do our grouping here. 6x squared minus 3x. 6 and 3, I could take out a 3. X squared and x, I could take out 1x. So I'm going to divide everything by 3x. 6x squared divided by 3x is 2, and then an x. Negative 3x divided by 3x, the 3 and the x cancel, so this is just a 1. Here again, this is the second term, has a negative, so let's factor out a negative. 8 and 4, I could take out a 4. There's no variables that I could take out here, so we're just dividing everything by negative 4. Negative 8 divided by negative 4 is 2x. 4 divided by negative 4 is negative 1. Again, these come out to be the same, so we did it correctly. So our answer from the AC method, we have 3x minus 4 and 2x minus 1. But don't forget the GCF that we had earlier. It just comes down as part of our answer out in front. So once again, we have to make sure and look for, do we have a GCF? And the common thing we're looking for, do we have multiple variables in it? Do we have numbers that are easily divisible? Those are things we're looking for as we go through. Remember, a GCF could be any set of terms, including a trinomial. And a trinomial has 3 terms, so we have to make sure we watch for that GCF.